Hello everyone, this is Direwolf20 and welcome to an updated mod spotlight for ComputerCraft version 1.6. ComputerCraft version 1.6 brings a lot of changes and a lot of cool stuff to ComputerCraft. I'm going to do this spotlight in a way a little different from the way I usually do spotlights. I'm going to cover like the easy and basic stuff that most people will be able to understand and enjoy early on in the spotlight, and then later towards the end of the spotlight I'll get in depth and do a lot more complicated stuff so that those of you who are really into ComputerCraft and like writing your own programs can understand the new features. So if you're not a big fan of ComputerCraft, don't worry, there's a couple really cool things that I think even you guys might enjoy. And if you are a huge fan of ComputerCraft and like writing a lot of code, you're going to love this update. So without further ado, let's start playing with ComputerCraft version 1.6. So as you can see here, I have in my hand a little pocket computer. These guys are pretty awesome. You can see here to get an advanced pocket computer, you need to get yourself a golden apple and a bunch of gold and a glass pane. Real easy to make. And regular pocket computers, same deal, just some stone instead of gold. And these guys work very similar to computers, but with some very cool and important differences. First off, let's take a look at what you can do with them. Well, first you have two basically. You can have a regular old advanced pocket computer, or you can get yourself the advanced wireless pocket computer, which has a wireless modem on it, and it's basically a computer that you can carry around in your inventory, and you can go ahead and run programs and do all kinds of cool stuff. So I can edit my programs like I normally would, and I can go ahead and do simple things like this. So here's a simple program that's going to go ahead and demonstrate for you guys the awesomeness of these pocket computers. They continue running when you don't have them open, as long as they stay in your inventory. So I can go run around and do whatever I want, and then, hey, look at this, I'm going to open up my computer, and it's still running. It's in the middle of running that code there that I just wrote. And then I can walk around a little bit more and access my chest and do whatever I want with things, and this program continues to run. So you can do all kinds of cool stuff with this. One of the suggestions Dan200, the author of the mod, gave me here was he said you could hook this up to a GPS network, and you could set it up so that whenever your player walks up to a certain door, it'll automatically open the door for you, because the GPS network would be talking from this little computer here, and the computer can tell the coordinates of your player in the world with that functionality. And there's all kinds of cool stuff you could do with this. So lots of things you could do. You could also use the wireless modems to control any other computers or turtles that you have in the world, so you could access your turtles and have them do things remotely using this little nifty gadget. Imagine having like a whole network of turtles that you can control wirelessly using this little handheld thing. It is awesome. So that is one of the cool things about it. And for those of you who aren't into writing programs, there's a very cool little Easter egg available for you. It's a game called Falling, which you might find a little bit familiar. Dun 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 dun. Oh, that's not good news. I'm going over here. Do you guys mind if I spend the rest of the spotlight just playing this game? Because I'm having a little bit too much fun. All right. We'll finish. All right, here we go. Oh, come on, so close. Give me a win here, would you? Oh, that's cool. All right, I promise. I'm done. So, yes, lots of cool things that you can do with these little pocket computers. It's a very nifty gadget. Now, to get them to turn off, keep in mind they have to be in your inventory to continue to run. If you take them out of your inventory, there's about, I want to say 3 to 4 seconds that it's available, and then you'll notice that it shuts off. You can tell because it stops having that little cursor animation. So once it leaves the player's inventory, it shuts off, and then once you right-click it, it starts again. But don't worry, as long as it's in your inventory somewhere, it will continue to run. He gave it a few second delay, so you could pass them to your friend, and your friend will have the computer still running again. But like I said, if it leaves your inventory for any length of time, it'll automatically shut itself off. So there we go, it's off now. Very cool wireless pocket computer. I'm going to be using and abusing this thing pretty hardcore in the future. The next feature that's really cool is a multitasking system that's available for only advanced computers and turtles. At the very simple method of manipulating it, you can go ahead and use the FG and BG commands to create a new shell window that can do things separate from the window that you're currently in. For example, if I did BG well, let's actually get a program going here. So what we'll do is I'll write another one of those test programs. So here we go, test, right? So if I ran test like normal, it would just start counting from 1 to 100 every second. But if I wanted to, I could run the bg test command. And what that's going to do is it's going to open a new tab here called test, where this program is running. And then I can go back to my other shell window and run another one if I wanted to, like that. Now I've got 2 running at the same time, in addition to my original shell. So you can have a bunch of different concurrently running programs doing a whole bunch of different things. So this is a really huge change for the way ComputerCraft works. No longer can computers do only one thing at a time. They can now multitask. And of course there's an API for your program so that if you want to be able to run different things and different shells, you're more than welcome to. If you want another shell, I think you can just do bg shell and you'll get another shell over here that you can then go ahead and do whatever you want. Now the other command here is fg, which is basically the same thing, but it instantly switches to that new window. So bg will just create the window in the background, so you can see it just creates it over here, whereas fg will go ahead and jump straight over to that window. Pretty cool, right? And all these different programs are running concurrently. How cool is that? And the way to close these windows is really pretty simple. Number 1, when the countdown is complete, or when the program ends, it's going to automatically close. So we'll wait about 30 seconds here for that to happen. So we'll notice here that this test window right here should close once we get to 100. There it goes, it's gone. And this one also will close once this one reaches 100. Cool. So that's how you can close out those extra windows. Now, if you have a bunch of extra shells open, you have 2 options. I think you can either just type exit, and that'll close out the current shell. So if I open a couple of these guys, and then I want to close this one in the middle here, I could just type exit, and he's gone. Or I believe you can do Control-T, and that'll kind of kill the currently running process, and that seems to work as well. So those are the multitasking functions. Like I said, there's some API things that you can run inside your programs that we'll get to a little bit later in the Spotlight once we get into the more in-depth stuff. Now the next big change comes to turtles. You guys know how much I love playing with turtles and all the nifty things they can do. Well, now they've gotten a major update in their functionality abilities. You can now, on demand, swap out what tools they have available to use. Check this out. I can just simply use the following command, equip one left, and boom, it went and equipped the sword. Check that out. And you can do the same with any inventory slot. So if I equip 2 on the left, we'll see that it swaps the sword out and puts the pickaxe there. And you can also have an item or tool equipped on the right. So now this guy has a sword on the right and a pickaxe on the left. And if we wanted to, we could go ahead and put a shovel over there instead of a sword. Yeah, there we go. Now we've got a shovel on the right and a pickaxe still on the left. And you can also do the same thing with modems. So if we went ahead and put a modem on the right there, you'd see, there we go, modem's on the right, and the shovel went back into the inventory. And then finally, if you want, you can also unequip either the left or the right, and it will go ahead and handle that for you. Cool. How awesome is that? So these turtles can, on demand, swap out what tools they have and, pretty much do whatever you want with these cool tools. I'm really excited about that change because there's a lot of neat functionality you could probably do with turtles now since they can have multiple peripherals on demand swapped in and out. That is awesome. And you might have noticed this little turtle over here with a name above his head. He's named Test. That's right, you can now label your computers in the same way as before. I'll do this. And they have their little names floating above their head. How nice is that, huh? And your other option is to throw these in an anvil with a name tag. So the same way you can label other entities, you can label the turtles with. It's just to be consecutive, but if you want, you can just use the label command still. It works the same way. Very cool. So the next thing that changed is Rednet, and I'll get into that in the more advanced part of the Spotlight, but for now I'm going to demonstrate one of the cool programs that you can use that really helps to spotlight what this thing is capable of. It's the chat program. So basically you can have one computer host a chat room, and you're going to want to go ahead and give it some kind of name. So I'll call it Dire Chat. Dun, 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 dun. Dire Chat is now running on this computer. And any other computers in the world that use the wireless modem here can go ahead and take advantage of that by also using the chat command. We'll instead join Dire Chat, and we can use a username. So I'll join Dire Chat here as Direwolf20. Hello everyone, this is Direwolf20. Welcome to Dire Chat. Haha, that's cool. And then if any other computers want to join in, they can simply join Dire Chat as another name. Like Soren. Hi all. Cool. And then these 2 chat rooms can see each other. Hi Soren. Hi Dire. while you do the things, etc., etc. So the chat program is really neat. It's just a little basic way that kind of shows off what's really capable with the Rednet protocols that were added. We're going to go into those very shortly. Another neat feature was added to the command system here. You can actually use wildcards now. So in the past, if we had 3 programs named test1, test2, and test3, and I wanted to delete them all, I'd have to delete them individually. Now I can simply do delete test star, and that will delete them all. So those of you who are familiar with the old DOS commands and that kind of stuff, wildcards are now available and can be used for this functionality. And one other functionality change is the Redstone program now has changed a little bit, and you can see the details if you do help Redstone, but no longer is it, he kind of like removed the old Redstone programs and added one overall called Redstone that you can use a whole bunch of stuff with. So you can do Redstone probe, will list all the Redstone inputs to the computer, so if we had a lever back here like so, we would be able to see that happening. So we'll do Redstone probe, and it should tell us that there's a Redstone input on the back. And the same here, Redstone probe, we can see it's now back and right, etc. And then you can also do Redstone set left true, or Redstone set right blue false. So you can modify just using the commands here, the Redstone stuff. And of course there's the API. I don't think it's changed too much for Redstone, but it's just the programs that you can use if you're not writing your own code or using the API. Pretty awesome stuff. So now is probably a good time to mention the help system, as that kind of wraps up all like the simple changes that I can demonstrate for you guys. Basically, go ahead and use help changelog to see all the cool stuff that's changed since the last update, and there's a lot of functionality listed in help. So you can do help FG to see that foreground program, help BG to see the background program thing, etc., etc. So a lot of functionality can be discovered using help. You can also check out that falling program. It's pretty neat, and a bunch of other stuff. So check it out. There's a lot of things you can learn by just using the help. Now let's dig into some of the APIs and changes that were made for those of you who like writing your own programs, because there's a lot of really cool stuff that got updated here, and I'm really excited to start using it in some of my ComputerCraft stuff in the future. So let's take a look at all the in-depth programmer content now. So remember earlier I was showing you guys the multitasking ability, where we can have a foreground of programs. So here's a new program I wrote. Again, it's just a test program, 1 through 100 every second, right? And you can do that from the command line. Well, you can also do this in the API. You can launch background or foreground processes in the API within your own programs. And let me show you how to do that now. It's simply using the shell.openTab command. And what you're going to do is pass it in the name of a program. So I've got that test program there. When I run this program, it's going to open a new tab and run the test program in that tab. And then there's another important command you should know about, switch tab. What that'll do is it'll switch to the tab by numeric number. So 1 is the first tab, 2 is the second tab, etc. So what I'm going to do here is I'm going to open that program, and then I'm going to switch to tab 2. I'm going to wait a second, switch back to tab 1, wait a second, and then back and forth about 5 times. Let's see how it works. Test multi. There we are. And we're switching back and forth. And we can see back and forth, back and forth. Pretty cool, right? So you can see here the test multi program is running, the test program is running, and everything's doing what we expect. Pretty cool. When test multi is done, keep in mind, so it just finished with its for loop, test is still there, and it's going to continue running in its own tab until this program finishes. So if you write a bunch of programs, or you want to run multiple things at multiple times all on one computer, you can easily do that with multiple tabs across the top, and they'll keep running in those tabs until either they finish running or you Control T to end the program. How awesome is that? So this shell functionality is really powerful for those of you who are really into writing your own programs and having multiple things, especially if you want to have multiple things happen at the same time, which is something I've usually wanted to have, and I've usually been able to find a way around it. But now, like, the possibilities are a little scary with how awesome this could be. And the same sort of functionality with turtles and the equipping that we saw earlier can be done with the following turtle API extensions, turtle.equip left. What that'll do is whatever the currently highlighted slot is going to be equipped on the left-hand side. And then we can do turtle.select 1 and turtle.equip right to equip the item in slot 1 on the right-hand side. Awesome. Do note that you can optionally use turtle.attack and turtle.dig functions and specify which side to use. So here I'm telling it to try and dig down with the tool on the left side, and it's going to tell me false. But if I tell it to dig down with the tool on the right side, it's going to tell me true, and it works. Do keep in mind, though, that this is completely optional, and if you don't tell it which side to use, it'll try with both. So if we don't specify, we can just say turtle.dig down, and it'll just work because one of the two tools is a shovel. So just keep that in mind. You can really kind of whatever you want to do with it. If you want to specify the left side, it'll try to use the left side and return false if it can't. And the wildcards. You can also use wildcards in the new fs function called fs.find. So the file system, you can do a find for all programs named test. But don't forget to put it in quotes. So if we did a find all files named test star, you'll get them returned in a table. So we can do something like this, and we should be able to textutils.serialize that data. And we should see test1, test2, and test3. You might also notice that textutils.serialize returns a little easier to read format, so it's a little bit simpler to read the data inside the array or the table when you're using textutils.serialize. But it still works the same behind the scenes, so you can still use it in your old programs the same way. It just looks a little better when printed out to the screen. Pretty neat. You guys might be familiar with crafting things. Well, there's a new little change to crafting. You can now say turtle.craft 0, and instead of actually doing the crafting, it'll tell you true or false if the crafting recipe in the turtle is valid. So if we try this now, it should return false, no matching recipes, and if we pop this in here again, it'll return true like we saw before. Without the 0 in there, it'll of course actually do the crafting. So it's a nice way to check if what you have is a valid crafting recipe if you're interested in doing that without actually doing the craft. So let's take a look at the Rednet functionality that's changed. A lot of what you guys are probably used to seeing is pretty similar, so nothing is really like not working anymore the way it was before. So everything works the same way it did before, but now there's a new option available within Rednet wireless modem communication, which is the protocol methods. You can actually specify a specific protocol to use when doing things like sending a message or receiving a message or broadcasting a message, and you can also set up hosts that really do some cool stuff. So let me show you how these work. So basically think of protocols like almost like a variable way of specifying like a subnet network on it. I'm not sure if that's really the right way to say it, but that's kind of the way I put it together in my head. So here's what I'm going to do. I'll demonstrate this and you guys can see if it makes sense to you. So what I'm going to do here is first off, I'm going to do a rednet.receive. Okay, pretty simple method if I can spell receive correctly. There we go. And if we wanted to real quick, we should actually check what ID this computer is. Okay, 4. So now rednet.receive. So as you guys are very familiar with, we can do the following. So we can do a Rednet send message, boom, and any computer that matches that ID number 4 is set to receive that message. So we receive the message, hello, right here from computer ID 3, which is this guy, right? Good. Okay, so we can see that's 3. This is now saying I got a message from 3. The message was hello. Pretty simple and straightforward, right? And we can do a similar thing with Rednet receive here. We can do rednet.broadcast. And what we don't have to do is specify which computer it goes to. Hello all. And every computer that's currently receiving a Rednet signal will get the hello all message, again coming from turtle number 3. This is the same functionality that we're used to. Now we can specify protocols in our Rednet receive, and I'll specify the protocol as dire. Okay. Now I'm only going to receive messages when the specified computer sends it on the dire protocol. Any other protocol, it's not going to work. Let's take a look at how this works. So if we're using rednet.send, we would do the same thing. We want to send to computer number 4, and I'm just going to send the message, hello. Because I didn't specify the dire protocol, he's not going to get the message. See, he's still sitting here waiting for a message on the dire protocol. So he didn't receive what he was expecting to receive. We have to specify the protocol by saying dire. Okay. Now he should have gotten that on the dire protocol. Cool, look at that. And you can see it also tells you down here which protocol it came over. So it's one of the messages returned from Rednet receive. It's not just the computer sending and the message that was sent, but it's also the protocol that it came over. How cool is that? Now, the other important thing here is when doing a broadcast. So imagine you had like 5 computers set up and you wanted to do a broadcast to some of them. You could tell like 3 of them to wait on the Dire protocol and 2 others to wait on the Dire 2 protocol, and then you could just do a Rednet broadcast and again, optionally specify. So if I don't specify the protocol, okay, he doesn't get the hello all message. Okay, but if I do specify the protocol, we'll see here, Dire, that he should get the message. There we go. So let's demonstrate this with multiple computers. So I've now got 3 computers set up. The one on the bottom says, send me a message on the Dire protocol. These 2 say Dire 2 is the protocol. Okay, so when I come over here and do a broadcast hello Dire, it should only broadcast to computers receiving on the Dire protocol, like this guy. But these guys did not get the message, because they're waiting on a different protocol. Now, if I want to broadcast on the Dire 2 protocol, and I'll say hello Dire 2, okay, this guy wouldn't have gotten it if he was in receive mode. He wasn't, but these 2 both did. How cool is that? So basically, if we're looking at this, we can use this to specify different channels to communicate over Rednet. That's one way to think of it. Different channels, different frequencies, different subnets, however you want to imagine it. But just imagine that he's only sending messages over the same frequency to those guys because they were all communicating on the same protocol or the same channel. It's a really powerful tool. So remember my old checkers program where I had a bunch of checkers that were black and a bunch of checkers that were red, and I had to keep a list of all the different IDs? Well, imagine that I just had all the black checkers waiting on the black protocol and all the red checkers waiting on the red protocol. Then I could do broadcasts to them, and I wouldn't have to send a message to each individual turtle. I could just do a broadcast across the red protocol, and it would go to all the red checkers. How awesome would that be? So there's a lot of ways that you can use this protocol method to do cool stuff. Now, if you don't like dealing with IDs, there's even better stuff that we're about to check out now, and those are called host names. So on the internet, you don't have to remember the IP address of a computer. You can just go to Google and you can see Google comes up. Well, behind the scenes, there's a computer IP address that's similar to the ID numbers in ComputerCraft. Now, you can do the similar thing with protocols and host names. So let's take a look. What we can do here is, for example, let's get rid of these guys to eliminate confusion, and we'll go back to the original 2 turtles we had. We can do a Rednet host like this, rednet.host. And we can specify the protocol that we want to work over. So I'll call it the Dire protocol. And we can give this guy a host name, Dire Turtle 1. Okay? And it's going to register that across the network. So now every computer that can talk over the Rednet within range should be able to find him by his name, Dire Turtle 1. So let's go find out. What we can do over here is do a rednet.lookup, and we'll specify the protocol. So we'll say Dire protocol, and then we can specify the computer host name, Dire Turtle 1. And it'll say response from 4, correct type, correct protocol. ID number is 4. So we didn't have to specify the ID number. I just sent out there and said, hey, anybody out there called Dire Turtle 1? And computer number 4 came back and said, yeah, hey, that's me. I'm Dire Turtle 1. Now, you can't have multiple computers with the same name. So if we went in here and we did rednet.host, so you can't have the same Dire protocol, Dire Turtle 1, we'll say, oh, hey, wait a second. There's already a host name called Dire Turtle 1. You're not allowed to use that host name. So this guy we're going to call Dire Turtle 2. Okay, that's cool. No problem. You're allowed to use Dire Turtle 2. So now if we come back to this guy originally and we say, hey, who's Dire Turtle 1 again? Oh, yeah, that's Turtle ID number 4. And who's Dire Turtle 2? That's Turtle ID number 23. That's me. So we track down this guy. And if we looked here, I would wager a guess that this ID is number 23. We are correct. And you'll notice that I'm not in Rednet receive mode or anything like that. So it's just registering the name out there saying, hey, if anybody asks for Dire Turtle 2, just tell them it's number 23. I don't even have to be set up here for this to work. But it will reset this when you reboot the computer. So if we reboot this thing here and we see that he's no longer online, if we come over here and ask who's Dire Turtle 2, we'll see that there is no response. Okay? So let's go ahead and set this guy back up because there's one more important and cool thing that we want to do. So I'm going to go ahead and set up on the Dire protocol, Dire Turtle 2 once more. There we go. Now it's working again. One more really cool feature, and that is called rednet.lookup, which we already saw, but you don't have to specify exactly which computer name you're looking for. If you want to, you can just specify the protocol name. So we'll just do dir protocol, and we'll see what we get. We got a response from 4 and from 23. So by saying, hey, who all out there is registered on the dir protocol? Both 4 and 23 came back and said, we're both on the dir protocol. So go ahead and feel free to message us. So it's a good way to communicate over channels. Once again, protocols are basically like channels or frequencies, whatever you want to think of them as. And you can say, hey, tell me everybody who's registered with their hosts on this protocol. So it's a real good way, again, to find a list of all the IDs out there. So what could I use this for? Well, you know how I always upload programs for you guys and I say you have to go in and change the ID to match your turtle? Not anymore. If I write my program correctly, I can register a host name in my program, and then I can use that host name in the other programs, and guess what? You don't have to edit any code. Those IDs are now no longer important. If I register my protocol names and my computer IDs correctly, you guys won't have to edit any code at all. They'll be able to talk to each other regardless of what computer IDs they are, as long as they register their names correctly. I think that's pretty cool. All right, we'll be back in a minute to check out a couple more features available in ComputerCraft 1.6. Oh, and a final note about Rednet. You can rednet.unhost, and you can specify the dir protocol, and that will remove this host from the protocol. So it removes that host lookup, so he's no longer sitting on that dir protocol. Now, to kind of go along with this functionality, he added the program called repeat, which is basically a way to repeat messages from computers over a long distance. So you know how there's a distance limitation within ComputerCraft, and if I wanted to communicate with modems that were like 500 blocks away, we'd need to build all kinds of complicated programs to do that, right? Not anymore when using the repeat functionality. So all you got to do to get this to work is run the repeat program, and since I don't want to travel 500 blocks away to demonstrate this, I've got 2 wired modems set up. I registered this guy named CC3. And over here, I've registered this guy named CC1. And this guy here, take my word for it, is registered as CC2. Now, if I went ahead and registered the command rednet lookup dir, on the dir protocol, there's computer ID 24 and 25, which is this guy and this guy. Okay, so both of these are communicating as we would have expected over a wired communication modem. And over here, we can't see CC3 because he's, not connected to the wired network there. So if we wanted to transmit these messages across this network over to this network, we can hook up a computer with a wired modem on one side and a wireless modem on the other. And the same over here. And then we have to simply run the repeat command on both of these. And what it'll do is it'll listen on one network and transmit it automatically across on the other networks that are attached to it. And if you have more than 2 modems hooked up, it should work just fine. So we've got this going here, and if I now that I've run repeat on both computers, just go ahead and do the exact same command, rednet lookup dir, we should get a response from 24 and 25 like we did before, but also get it from 27. Cool. So we can see now that we're able to talk to this computer. And if I went ahead and did a rednet.receive, like so, and if I tried to send a rednet message like this, hello, it should communicate just fine. Look at that. It got the message hello from computer number 25, even though they're not on the same network. It's because these guys are repeating. If these guys were not repeating and we did the exact same functionality, rednet receive and rednet send 27 hello, it would not get the message because these guys can't communicate with each other directly. They have to have the repeaters turned on. Now, of course, if I wanted to, I could have a wireless modem attached on this guy, but this is more to demonstrate how you can do this across long distances, or if you really wanted to, you could have a basic network inside your base and then communicate with like a satellite station up in the sky that retransmits your message to other computers across a distance. Because remember, the higher up in the sky a computer is, the longer range it has for RedNet communication across wireless modems. How cool is that? I think it's awesome. Finally, there's a new API that comes along with any kind of really screen or terminal or monitor. In this case, I'll demonstrate this on a monitor. It's called the Window API, and it's pretty neat. Let me show you how this works. So a new API has been added that's going to be kind of interesting and a neat way to do stuff. You can see I've got this word hello here on the monitor. We're actually going to be able to specify certain windows within or like subsets of monitors, and we'll see how this all works right now. Let's play with it a little bit. So what I'm going to do first is show you how to create a new window. And what we have to do is first define a variable. I'll just call it win, and we're going to create this window by doing window.create. And first we have to tell it where to create it. So I'm going to give it the peripheral that we've already wrapped, the variable there, mon. So we're going to create a window on the monitor, and then we specify the x and y coordinates of where to create it. So I'm going to do 5, 5. So that's going to start right up here. I put the word hello at 5, 5, so you can kind of see where that works out. Okay, and then we're going to specify the width of the window. So we're going to make it about 10, and we'll specify the height. We'll make that 3. Okay, and then finally you can tell it whether or not to be visible initially, and I'll show you what visible means in a minute. So for now, what I can do is mon.setCursorPosition 1, 1. Okay, and then we're going to mon.write hello, and this should write onto the monitor in the top left corner. Cool, it did. Awesome. Now what we can do is go ahead and specify. Let's do mon.getCursor position just so we can see where it is. It's currently at x6, y1. So that's sitting right there after the word hello. That's where the cursor currently is. Now if I want to write to the window, I simply do win.write hello window, and we can see that the word hello is positioned right there. So now it's started in that window position. So we've defined a little window that's sitting right here, and we can see exactly how it works out. Now remember, I only made the window about 10 characters long. So if I write the word hello there, what we should see is that it actually cuts off the word hello after the 10th character. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it cuts off. So that window is only this large. Okay, and if we wanted to, we could also do the following. We can do window.clear. Cool. And we can see it cleared the window, but it didn't clear the monitor overall. We could do win.setBackground text, set background color, I think it is, and we'll do colors.light blue. Hey, we'll see if that works. And then we should also check out that we can do win.getCursorPosition, and we'll see that it's currently in position 19 within the window, but the window is only 10 wide, so it didn't really work out. So we'll want to do a win.setCursorPosition 1, 1, and then we can do win.write hello. And we'll see that that window is written just like that. Pretty neat, right? So this is a subset of this guy. Now, if we come over here, there's one thing you should note is when you do a mon.getCursorPosition, because we're working within this window, it's also updating the cursor position on the monitor as well as the window. This is something that might not be apparent right away. So keep in mind now that your cursor position for your monitor is also moved relative to the overall monitor. So keep that in mind. If we do a win.getCursorPosition, we'll see the cursor position relative to the size of that window. So the cursor's in the same spot. It's just overall this is spot 10, 6, but within the window it's spot 6, 1. Cool. And there's, of course, pretty much very similar and standard functionality that you can do with Windows is similar to what you can do with monitors, but you can do some other cool stuff. Like, for example, you can get win.getSize, and you'll be able to see that it's, in fact, a 10:3, like I specified it earlier. And you can also do win.setVisible. And this is actually pretty interesting. So let's do this. If we win.setVisible, it's not going to automatically clear the window for you. So what we're going to want to do there is a win.clear and a win.setCursorPosition 1, 1. When the window is not visible, any new text you write to it is not going to be immediately apparent. So let's check this out. So we can see here that we've cleared this guy, this little window, and he now has his full background text available, or his background color of light blue. And I'm just going to do a win.write hello. Oh wait, let's clear that again and actually specify false without quotes, because that was a dire derp. All right, so now we've got that guy visible false. If I now set it to clear, we'll see that the box is there. And if I go and do a win.write hello, it actually doesn't write anything because the window is not currently visible. Interesting, right? Now, if we have the window visibility false again, and we do win.write hello. Like I said, you're not going to see it until you set it to true. So now if we do win.setVisible to true, we should see the word hello automatically show up over there. Cool. So there's a lot of neat things you can do with this. You can also do a win.redraw if you want, and that will redraw it in case something has overwritten it. So a demonstration of that might be monitor set cursor position, we'll say 5, 5. I'll do 3, 5. So let's say that you wrote over this. Oh noes. See how I just kind of wrote over that right there like that? Okay. If we do a monitor or a window.redraw, what we should get is that word hello redrawn right inside that monitor. So it retains that data that was there, even though it was written over by the monitor. Doing a redraw will redraw that window. Very cool stuff, and a very neat and interesting way that you could go ahead and manipulate your monitors in a really good way to, kind of control stuff on the monitor where it's printed and keep those little windows like that. So you're definitely going to want to go through the help functionality for Windows so you can kind of see how these different things work. It's a pretty neat thing. Another cool thing you might want to check out is a little change to the way you can wrap peripherals. So we've been kind of messing with this a little bit. So let's go ahead and check this out here like so. Normally you'd have to wrap the peripheral by destination. So like here if we go into Lua and let's reboot this guy, just so we get a nice fresh thing. Normally we'd have to do monitor is equal to peripheral.wrap left. Right? Well, maybe I know that I'm trying to wrap a monitor here, but I don't know which side it was put on. Again, if I'm uploading code for you guys, I'd have to tell you, don't forget to go and change what side your monitor happens to be on. Well, this is pretty cool. Check this out. You can do peripheral.find, and then if you don't specify anything, I don't think it works, so you have to tell it what to find. And I'm going to say, go ahead and find the nearest monitor. Boom. And now we can do mon.clear, mon.write, hello, etc., etc. And you can see that now that monitor wrapping is complete. So you can use the find functionality and you specify the type of the monitor. So if we want to do modem is equal to peripheral.wrap modem, we get that modem wrapping right back there. Pretty cool, right? So peripheral.find is the way to do this. Pretty nifty, right? So it's a good way to, say, find me a modem. And if you have multiple modems or multiple monitors hooked up, it'll return as an array. So then you can, or a table as it is called in Lua, and you can go ahead and access it that way. So here's a minor change to Turtle functionality that I absolutely love. You ready for this? Check this out. We're all familiar with turtle.suck, right? Yeah, he can go ahead and pull the all contents of the first slot it finds in the inventory. Boring, we've seen that a million times, right, Dyer? New functionality to turtle.suck, you can specify the limit, the number of items pulled out. So if I had turtle.suck 5, it'll only pull 5 items at a time. And turtle.suck 10, it'll only pull 10 items at a time. How awesome. So a little bit of an improvement to turtle.suck, but I really kind of like that change. I think it's very, very cool. And as you can see, the same functionality now exists for drop as well. You can drop 5 items at a time, and it'll work just fine. And with that, guys, I'm pretty sure we've hit the wrapping up point for the ComputerCraft version 1.6 Spotlight. It's a massive update. I mean, this is probably one of the largest ComputerCraft updates I've seen in quite a while. I mean, tons of functionality changing. The ability to swap turtles on the fly and multitasking computers is pretty much insane. And I really like the changes to Rednet, having different channels on Rednet and being able to set up host names should make things a lot easier, especially for when I want to, write some cool program and distribute it for you guys. You really shouldn't have to change almost anything at all and be able to use it. And it'll just make writing programs that much easier. So if you guys stuck around to the end here, I hope you enjoyed it. And there's, of course, some really nifty functionality like the wireless pocket computers and that kind of stuff. So this is Direwolf20 signing off. Hope you guys have enjoyed the Spotlight. And as always, take it easy.